Hi everyone, welcome to Vishwablooms. So in this video we'll be looking at mathematics bridge course for class 11 or intermediate. So after 10th you can actually see this bridge course series. It will be very helpful for you. So this is the third lecture welcoming you all. So in this third lecture we are going to see a topic called sets. It's very important, the sets topic. Okay. So if you are from CBSE 10th standard and if you are moving to state board intermediate, then this is very important because this topic is already being covered in the 10th grade as a state board for some of the states. Okay, so that's what. So it's very important actually, and for those who are going to 11th standard, this will be there already in the syllabus for you. Okay, so it will be there in 11th standard CBSE textbook also. So let's just have a basic idea so that this will become more easier for you in 11th and intermediate. Okay, if you're opting for intermediate or state board, then this topic will not be there for you. Directly you will have to move to the chapter. So this sets why they will actually teach us. This is very important for learning functions chapter. There will be chapter functions for both the boards, central board and state. So for that it will be very easy. Functions, okay, so very important. That's why this lecture is very important. So let's start. So first we will see the definition of sets. A set is a collection of well defined objects which are distinct from each other. That's it, simple definition. Okay, collection of some objects which are well defined and they are different from each other. That's it. Okay, now generally sets are represented with capital letters. Okay, represented by the capital letters. Okay, then we need to know something called elements. So whatever the members of the set, all the members of the set are called as elements. So these elements, they are generally represented with small letters only, small letters of English alphabet. How to write a set first we will see. So how to write a set. Suppose if I have to write a set A which will represent all the vowels of English alphabet. Set A you should write first, okay, then you should put is equal to. In the flower braces or curly brackets you should write the particular elements of this. Okay, elements are nothing but all that vowels A, E, I, O, U. So these should be enclosed within the curly brackets. This is very important. Okay, I have to discuss these two things. Okay, so first I'll introduce them first. This is something like this, right? It looks similar to E, but this is called as belongs to. When you want to write belongs to, you can simply use this symbol, and when this symbol is cut, does not belongs to. Simple, does not belongs to. If I have to tell that A is element of set A, then I can simply write it as A belongs to set A. That's it. Okay, very simple. Now if I have to tell that B is not an element of set A, then I have to write it as B does not belong to sign I have to use and set A. So these are two important things which you should know. Okay, so that is one thing. Okay, so now let's move on to methods to write a set. First we have seen how to write a set, right? Now methods to write a set. So there are generally firstly two methods are there. First one is the rooster method or tabular method. Second one is the set builder form. Set builder form, or you can call it as property method. Okay. First we will discuss what is the rooster method. Generally in this method what we use is the set whatever is there. No, set is described by listing the elements. So set is described by listing the elements. So what are all the elements present in the particular set, we will list them out. how we list things, right? In that way we will list them, and they are separated by commas and enclosed within the curly braces. So I have already told you commas and curly braces must be used while writing a set. So commas after a element and curly braces it should be enclosed within. And while writing in the set rooster form, a element should not be repeated. Only once you should write. I already told you, right? Now, if I have to write the set of letters for word Vishwablooms, say Vishwablooms only. Okay, how will I write set? So set A is equal to V, I, S, H, W, A, B, L, O, again should I write O? No, it's completely wrong. O, even though it is there 2 times in our channel name, but you should write only once when you are representing in the rooster form in sets. Okay, so only once O you will write, and again you will write M, and S again will you write? No, here already S is there, right, in Vishwa. So you will not write. So this is the set for Vishwablooms. I hope you understood, right? Yeah. So you can similarly do for any simple word also. It is the same thing. Now we will see the second form, that is set builder form or property method. So in this method what we do is we just write down a property or rule for that particular set. So property or rule which gives us all the elements of the set. So using this property or set we can find out all the elements of the set. Now if I suppose for example I will take a set A which expresses x, where x belongs to natural number. If I write this, it is very simple. The set A is representing all the natural numbers. Now if you want to know x, you know how it is very simple. A is 1, 2, 3, 4, so on till infinity, because natural numbers are many till infinity. So you can give a condition for that particular set. So actually A is a set of natural numbers. Very simple. Understood? So that is what is this set builder form. Here in the rooster method what we will do is, in rooster form we will list everything, list all elements. Okay, but whereas in set builder form what you will do is you will give a rule or a particular property for that particular set. Understood? That's it. Okay, now we will see how to write a rooster form set in a set builder form and set builder form set in rooster form. Okay, we'll see how to do that. So first I have 2 examples here. So first we will see the first one. So express set A is equal to x, where x belongs to natural numbers, and x is equal to 2 power n, where n is the natural number in rooster form. So they are asking us this condition is given. No, it's actually in set builder form. Am I right? So they are asking us to write it in the rooster form. So first x is natural number and x is 2 power n. So n is any natural number, right? So n is 1. If n is 1, x is equal to 2 power 1 is 2. If n is 2, x is equal to 2 square 4. If n is 3, x is equal to 2 cube 8. So the list will continue like this. So what are the elements of A actually? They are 2, 4, 8, 16, so on, right? So on. So this is how you need to solve this particular type of things. Like you can convert them into rooster form. Now in the second example I have an example in rooster form. This is already in rooster form. Now I have to convert it into set builder form. I have to give one condition. So for the so on I am putting. Okay. So how do I create the condition? All these numbers you observe it very carefully. First and foremost observation will be like the 1 is being added to all the square numbers. That is only your observation I am hoping. See, 2 is nothing but 1 square plus 1. 5 is nothing but 2 square, that is 4 plus 1, 5. 10 is nothing but 3 square 9 plus 1. 17 is 4 square plus 1. So the condition is n square plus 1. That's it. Okay. This is how you build a condition. That is in set builder form. So what is the condition for this? A is equal to n square plus 1, where n belongs to natural numbers. Sorry. That is what is the condition. That's it. Simple, right? So I hope you understood this. You should be practicing more examples and it will be just very simple. Now we will see types of sets. Actually there are many types, so we need to understand them very clearly and we will learn them. First is the null or the empty set. So null set is nothing but a set having no elements in it. When there are no elements in a particular set, then it is an empty set or null set or void set also you can call it as void set. So if there is usage of any of these words, you should be able to understand that there is no element. We will take an example for this set. Suppose he is telling here is a set of numbers of even primes other than 2. What are the even primes other than 2? There are no even primes other than 2, right? So this condition, there are no elements that there is going to be. So you will just simply denote it as this way. You will denote it this way or you will write it in this way. You will just put null symbol like this. Okay, denotion I'll show you once again. Understood? Next is a singleton set. Singleton set is nothing but a set containing only single element. Only one element if it is there. Suppose if I give you an example, set A containing all even primes. What are all the even primes? Only one number, that is 2. So A is just 2. So only one element is there. So this is a singleton set. Clear? Next we will see finite set. So finite set, the word itself is telling that the set which has only finite number of elements. So if I ask, write A is a set which tells all the vowels in English alphabet. There are only 5, right? Fixed. That is A, E, I, O, U. Only these are there. So these are fixed. So it's a finite set. Next we have to see cardinality or cardinal number of this set. That is order of a set. So you can use multiple words. Okay. So you should be very careful in this case. If the word order, cardinal number or cardinality is used, it is just referring to the number of elements in that finite set. Now suppose this set only we will see. This is a finite set, right? So cardinality, how you will write is n of the set. This is how you represent. Okay, you represent it as O of A or else n of A. So what is the cardinality of the set A? It is 5. Am I correct? So that's how. Next, infinite set. Again, this also, by the name we can understand, it has infinite number of elements. So for example, consider set A which is completely natural numbers. So there are many natural numbers, right? So this is an infinite set. Clear? Next, we'll first equal sets. See, two sets A and B are said to be equal if every element of A is member of B. Every element of A is a member of B and every element of B is member of A, then only they are said to be called as equal sets. So suppose if I have set A which represents 1, 2, 3, 4 and I have set B which says 4, 3, 2, 1, is there any difference? Both are same, right? So every element of A is element of B. So these are called as equal sets. Okay, in that case we will just write A equal to B. If they are not equal, A is not equal to B. That's it. Okay, same thing should be there. That's it. Then what is equivalent set? Again, these are two finite sets A and B where their cardinal number is same. That means n of A equal to n of B. Then they are called as equivalent sets. Say, suppose A is 1, 2, 3, 4 and B is 4, 5, 6, 7. Then they are called as equivalent sets. Okay, because here also 4 elements, here also 4 elements in that set. That's what they are called as equivalent sets. Okay, equal sets are always equivalent sets. That is a note point, because same elements means obviously same count also will be there, right? Here 1, 2, 3, 4, 4 elements, 4, 3, 2, 1, 4 elements, it is going to be the same thing. That's what. Okay, equal sets are always equivalent sets, but equivalent sets need not always be equal. So in the down example in the previous page, you can see these two are not equal sets, but they are equivalent sets. Okay, so I hope you understood the difference. Next we need to see something important, that is subset and superset. Again, let A and B be two sets. Okay, now if every element of A is an element of B, then A is a subset of B and B is superset of A. Consider a set A as 1, 2, 3, 4. Okay, and consider set B as 1, 2, 3, 4, 5, 6, 7. See, all elements of A are there in B also. So that's why A is a subset of B. Whereas, see, there are more elements in B, right? There are elements of A as well as other elements also. So that's why it is the superset of A. Okay, so that is the difference between subset and superset. We will see that how to denote a subset. Okay, so if A is a subset of B, how do we represent it in this way? So A subset B. So this is a symbol for subset. The direction is very, very important. Okay, the direction shows which is a subset, which is a superset. See, this is showing towards this, right? It's towards B. That means this is a superset and this is the subset. So this U, wherever it points, that is superset, and other one is subset. Now proper set. Now if A is a subset of B, A is not equal to B. That means A and B are not equal sets. Then only A is called the proper subset of B. Okay, so if they are not equal sets, then only they are called as proper subset. If not, they are called as improper subset. Then we will say A is improper subset of B. Suppose if A is not at all a subset of B, then you will just scratch that subset symbol. That's it. Okay. Next, we need to see few note points. First and foremost thing is that every set is a subset of itself. Second point. Okay. So when they are asking you to count the number of subset, you must not forget that set only. Okay. Next, second one, empty set or void set. Just now we learned, right? This is the way we represent. This is a subset of every set. Okay. Third point, if A is a subset of B and B is a subset of A, then these are equal sets. That means A equal to B. Clear? So this is one condition you should remember. Next, the total number of subsets of a finite set or containing n elements is 2 power n. This formula is also important, because if somebody is asking you the total number of subsets for that particular set, then how will you find? You will use this formula 2 power n. Okay. Now if somebody is asking you the number of proper subsets, that means not including itself, right? Improper subset is including itself, proper subset is not including itself. So that is 2 power n minus 1 is the formula. Suppose I'll give you an example. See, suppose A is 1 2 3, A set is 1 2 3. See, 1 2 is also a subset, 1 is also a subset, 2 is also a subset, but 1 2 3 should not be this subset, okay, because proper subset will not have that, right, because equal it will become. So what are all the subsets for this? We'll try to calculate. Okay, 3 elements are there, 2 cube minus 1, so 8 minus 1, there will be total 7. You can just write all the subsets if you need. Okay, 2 3, 1 2 we already wrote, 3 1, so 3 is also a subset for itself, right? Here null set is a subset of every set, no, that is what is missing. So here you can count, there are 7. See, empty set is a proper subset of every set except itself, okay, it's a proper subset only. Okay, now we have to see power set. So the set of all subsets of A is called as power set of all subsets. Okay, now maybe you will not understand by seeing the definition of this, but I'll make it clear with an example. So you will denote it in this way, P of A. If it is a set A, you will denote it as P of A. Okay, so now I will take a simple example. A is a set of 1 2 3, including 1 2 3, that's it. Now write off all the possible subsets. Okay, so first is null set, don't forget null is a subset of everything. Then write 1 2 3 itself, it's the set itself is a subset of itself, right? We have just seen the point. Next just write 1 2 and leave 3. Next write 2 3, leave 1. Next write 3 1, leave 2. Okay, and next write 1 2 3 individually. 1 2 3, how many are there? 8, right? So this set is there, no, this is called as a power set of this set. That's it, this is the answer. Understood? That's all. Now we will see one more important thing, that is universal set. Very important. Okay, this is a set consisting of all possible elements which occur in the discussion is called as universal set, and this is denoted by the letter U. So when you are writing U, it's nothing but universal set, or you can use the symbol mu also. So now we will see few operations on sets. So some operations on sets are, first you will see union, then intersection, difference, and we will see complement of a set. Union is generally denoted with this symbol, it looks like U. Okay, so that is the symbol union. So if I have to find out the union of two sets, then I have to write it as A union B. Okay, in this manner I am going to denote it. So A union B is nothing but it's a set X where X belongs to A or X belongs to B. Okay, X belongs to any of the set, A or B. Now maybe you will not understand clearly with this, so I will take an example in order to show this. So A is a set 1 2 3, B is a set 2 4 5. Then if I have to find A union B, then I have to write it as 1 2 3 4 5. It's nothing but union is simply adding up things, writing both the things together, okay, both the set elements together, that's it, is union actually. Okay, here 1 2 3, you have written 1 2 3, here 2 4 5, so 2 it should not be repeated in a set, right? So 4 5 we have written, that's it. Okay, so now we will see intersection. So intersection is usually denoted in this way, ulta U. Okay, so if I have to find out A intersection B, it is set of which says X, where X belongs to both A and X belongs to set B. So I'll make it clear for you with an example. Okay, suppose A is same set 1 to 3 and B is set 2, 4, 5. So now if I have to find A intersection B, what I have to do is I have to find out the things which are in common in both the sets. So what are the things which are common in both the sets? Only 2 is common. So that is the element present in the intersection set. Now we will see difference of two sets. Okay. So difference you all know, right? With minus sign we will indicate this. Okay. So A minus B is equal to X, where X belongs to A and X does not belong to set B. Very, very important. Okay. It should not belong to B. Now I will say take same example, set 1, 2, 3 and B is a set 2, 4, 5. Now if I have to find out the difference between these two sets, that is A minus B, so A should be, this X should belong to A but it should not belong to B. Okay, so answer is 1, 3 because 2 is present in second set, right, B set, whereas 1 and 3 are belonging to only A set. So that is the answer. Now if I have to find B minus A, B difference A or B minus A, then answer is going to belongs to B and X does not belong to A. This you should follow. So it is going to be 4 and 5. 4, 5. Okay, I hope you understood this union, intersection and difference. So these three are important because these only majorly will be using in sets and functions. Then we have the fourth thing, that is complement of a set. That I'll just show you how to represent it. A dash. See, if A is a set, then its complement is A dash. That's it. So A dash is a set of where X does not belong to A and X belongs to universal set. Now for example, universal set is from 1 to 10. Actually you should write it in dot form. On my screen dots are not so easily possible, that's why I put a dash. Okay, should put dots instead of that. Suppose it is a set from 1 to 10 and A is a set starting from 1, 2, 3, 4, 5. Now if I ask you to write the complement of set A, that is A dash, you should be able to write. It's very simple. 6, 7, 8, 9, 10. That's it. See, these are the elements which are not present in set A. They do not belong to set A, but they belong to universal set. This is the condition, right? And we need to move to some important topic, that is Venn diagrams. Venn diagrams are very essential for intermediate or your 11th and 12th. Okay, so the relationships between sets can be mostly represented by the means of diagrams which are called as Venn diagrams. Okay, so these diagrams generally consist of a rectangle for universal set. So if you want to indicate a universal set, that is U or mu, so if you want to indicate a universal set, you need to draw a rectangle, very important, and circles for the subsets in the rectangle. So subsets, if you want to show, you should put circles in that particular universal set. In that particular rectangle you will be putting these circles. Understood? So the elements of the sets are written in the respective circle, respective set, respective circle. In that only I should write the respective elements. Okay, now I'll give you an example so that you'll understand very clearly. Suppose A is a set of 1, 2, 3, B is a set of 4, 5, 6, and A and the universal set I will write. U is a set of 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so let this set end universal set. So first you will represent the universal sets in a rectangle, right? I am representing it with mu here. Okay, first draw a rectangle. Now here we have two sets, A and B. So these are the subsets of that. First you will draw one circle. This is for A. You will represent it A. Okay, that is a subset name. You will write 1, 2, 3, and you will make one more circle and you will name it as B subset. You will write it as 4, 5, 6, and whatever are not there in this A and B, you will write it outside. So what are not there? 7, 8, 9. So this is how you represent it. Okay, now we will take another example. I'll change the B set. Okay, I'm changing B set as 3, 4, 5. Now the Venn diagram will immediately change. Okay, universal set is same like this, only rectangle. So first you will draw one circle here. You will write all its elements. First I am making A subset. Here 1, 2 and 3. Now in B subset also you have 3 in common. So you will not write it again. You will circle from there and write 4, 5. And remaining elements outside the circles. Here you will name it as B. I hope it is clear to you. Okay, in this way you have to write. Now suppose here also if it is 1, 2, 3, only one circle. Okay, you will draw upon that only. Suppose this B set was 1, 3, 5, then 1 and 3 will be here. Okay, so that's it about Venn diagrams. It's union, intersection and difference using Venn diagrams. How we can solve, we will see them. Okay, few we will see, then we will move on to the next part. Now for this particular question we will do all the things like union, intersection and difference. We will try to find out. So first I have given the universal set. I have given A, I have given B, two subsets. So union, intersection and difference, how to solve by mind I have already told you. By using Venn diagrams and how to represent it in the Venn diagrams I will tell you now. First we will see A union B. Okay, so A union B, how we will represent it first we will see. First rectangle as usual, because this will denote the universal set. Okay, now first we have A set. This is a circle and here we have elements 1, 2, 3, 4, 5. Now again we have B subset which have 4 and 5 in common, so that's why like this. And what are all left? What are all the things which are left? 8, 9, 10 will be outside. Okay, this is how you will show. Now if I have to show that this is union, okay, you will have to shade everything like this you need to shade it. Okay, you can do it neatly with pencil. Here it is screen, right? I have to do it in this way only. So you are like this, you have to shade everything. Okay, that is union. Now if I have to show intersection, I will change it to. Now showing intersection is very easy. This common part whatever is there, no, that only you should shade it. That's it, over. Okay, now I will show you difference. A minus B first we will see. So whatever the things which are present in A set and which are not present in B set are generally, it is nothing but A minus B. That is what is the condition. So you need to shade things which are there in A and you should leave the rest. So in this way you should shade. You should not shade 4 and 5 because that is belonging to B set also. Understood? So this way all this you can shade it, remaining you should not shade. Okay, now we will see B minus A. So this case is actually which will belong to B and which will not belong to A. So you should shade this part. Understood? This way you should shade these things. Understood? This is how you will just generally show, representations I am explaining. Now if you want to show complement of this, so I'll show for A set complement. Okay, simply draw one rectangle, take a set A, write 1, 2, 3, 4, 5 only are there, sorry, and this is universal set. Whatever is so if I have to show A dash complement, so shade everything other than this circle. That's it. It's only complement representation. Other than the circle, everything you can shade. That's all. This is complement of a representation. So now I hope it is clear to you. Okay. Now we have to move on to the properties of sets, which are a little bit essential for solving the problems. Okay. First is commutative law. So A union B is nothing but B union A. Both are same, and A intersection B is also nothing but B intersection A. This is not the same with the difference. I am telling again, A minus B is not equal to B minus A. I already showed you the difference also, even though once again I am telling, okay, this is not equal. That's what this is not a commutative law. Next we will see the distributive law. If A union B intersection C, if you have to solve, then you will do it as A union B intersection A union C. Okay, like how we did in our childhood, same thing. Suppose if we had 3 into 2 plus 5, what we did? 3 into 2 plus 3 into 5. That only we did, right? Same thing here also, but union and intersection, that symbols, that's it. Okay. Again, if you have A intersection B union C, you can just write it as A intersection B into union A intersection C. So these are few laws. Okay. This is essential for us. So I have covered sets, whatever is required for the 11th standard and intermediate. I have covered everything. So I hope you like this video. Do like, share, subscribe to Vishwablooms. Bye bye. See you in the next video.